Dear students, the term isostasy is derived from isostasios, a word of Greek language meaning a state of being in balance. You already know and must have seen that the mountain have many peaks and relatively great heights. Similarly, plateau and plain have flat surfaces. They have moderate and lower height respectively. On the contrary, ocean beds and trenches have greater depths. There is a great difference in height among these features. You also know that the Earth is rotating while keeping perfect balance among its various features. Thus, our Earth is considered to be in isostatic equilibrium. Let us try to understand this using a simple example. Suppose you are holding one stick each in your both hands vertically with varying height, say 5 meter and 15 meter, and you are moving in a particular direction. Do you have any difficulty in maintaining a balance in congruence with your body as well as two sticks together? Definitely. Smaller stick will be easy to make a balance than the longer one. It is just because of the center of gravity. The center of gravity with smaller stick will be nearer to your holding hand in comparison to the longer stick. In the same way, smaller surface features like plains are more stable than the tall mountains. Airy, a geologist, considered the density of different columns like plains, plateaus, and mountains to be the same. Hence, he proposed the idea of uniform density with varying thicknesses. You know that the upper crust of the Earth is made up of lighter material. Silica and aluminium are found in abundance. Hence, it is known as Cl. It is less dense than the lower one. Airy assumed that the silic crust is floating over the sima, that is silica and magnesium, lower denser layer. Crustal layer is uniform in terms of density with varying lengths of columns. Therefore, those columns are projecting down into the asthenosphere depending upon the proportions of the column. It is due to the reason that the root has developed or the sima has been displaced from below. To prove this concept, Airy took an example of wooden blocks of various sizes and immersed them into water. All blocks are of same density. They get immersed differently in proportion to their sizes. In the same way, higher features with great height seen on the surface of the Earth have deeper roots, whereas short in length has shorter roots beneath. It is the concept of root which is sustaining the higher elevation. He was of the opinion that the land masses are floating like a boat in the substratum of magmatic asthenosphere. Floating ice is 8/9 submerged, and the higher the ice rises above the water level, the deeper is the submerged proportion. Thus, the roots of the mountain sink in the basaltic substratum to depths proportional to the heights above. This has greater support from recent geophysical data. For example, Mount Everest in the Himalayas rises to a height of about 9 kilometers, whereas right beneath it, the crust is about 80 kilometers thick. Thus, Airy suggested that blocks of the lithosphere had a constant density of 2.7 gram per cubic centimeter and floated in the asthenosphere of density 3.3 gram per cubic centimeter. Views of Pratt. Pratt considered land blocks of various heights to be different in terms of their density. The taller land masses has lesser density and smaller height features to be denser. In other words, there is an inverse relationship between height and density. If there is a higher column, density will be lesser. And if there is a shorter column, density will be higher. Assuming this to be true, he accepted that all blocks of different height get compensated at a certain depth into the substratum. In this way, a line is being demarcated above which there is equal pressure with varying heights. Thus, he denounced the root concept of Airy and accepted the concept of a level of compensation. For proving this concept, he took a number of metal bars of varying density with same weight and put them into mercury. In this way, they form a line by all those bars, which he regarded to be the level of compensation. Differences between the views of Airy and Pratt. Let us try and understand the differences between the views of Airy and Pratt more clearly using the following table that you are about to see. Global isostatic adjustment. Dear students, isn't it quite apparent that there is no complete isostatic balance over the globe? The Earth is unstable. Endogenic forces often disturb the crustal balance. The regular earthquakes and volcanic eruptions along a particular belt do not signify any balance, but a sort of adjustment is needed continuously. Endogenic forces and their tectonic effects are the causes of imbalance on the surface, but nature always tries to make an isostatic adjustment with itself. Exogenetic forces are trying to eliminate the differences on the surface of the earth, and in this process they are peeling off, transporting down to far-flung places and depositing there. In this process, isostatic balance is maintained by the underneath flowage of material by subsidence at the place of deposition and upliftment at the peeling of place in their proportion to the denudation. Heiskanen's theory. The assumptions of both Airy and Pratt have been combined in this theory. Here it is assumed that the density varies both between crustal blocks and within each block. It has been observed that the average density of rocks of sea level is more than those at higher elevations, and this variation of density are thought to continue further downwards, causing the deeper rocks more dense than the shallower ones. Thus, different blocks are thought to have different densities and accordingly extend downwards to different depths. It explains for the roots of mountains and for the variations in density in different parts of the crust. The theory of isostasy convincingly explains the vertical upliftment of the mountains, but it has not yet been possible to establish that isostasy is the factor initiating tectonic movements. The role of isostasy in the developments of the Earth's crust is rather modest and not decisive. The idea of isostasy is supported by the fact that the melting of ice from the glaciers in Scandinavia led to a reduction of load and a consequent rise of the area. The theory of isostasy is also confirmed by the seismic data. Continental drift. In 1915, the German geologist and meteorologist Alfred Wegener first proposed the theory of continental drift, which states that parts of the Earth's crust slowly drift atop a liquid core. The fossil record supports and gives credence to the theories of continental drift and plate tectonics. According to Alfred Wegener, the entire landmass of the globe was together about 280 million years ago. It was termed as Pangaea, a supercontinent. The huge water body surrounding the Pangaea was known as Panthalassa. From 280 to 150 million years ago, Pangaea was broken latitudinally into northern and southern parts known as Laurasia or Angara land and Gondwana land, respectively. Both of them drifted away, and in between a shallow sea emerged by filling up the water from Panthalassa. It was known as Tethys Sea. Later on, Laurasia and Gondwana land rifted and finally drifted to form the present-day distribution of land and water on the Earth. Evidences of drift. Wegener gave a number of evidences in support of the unification of landmass in geologic past. They are such which cannot be negated even today. A. Jigsaw fit. Eastern coast of South America is identical to western coast of Africa, which fits to a certain depth in the ocean. To a certain extent, coastal areas and continental shelves have been modified by oceanic waves through denudation. B. Geological similarities. The mountain systems of southern Atlantic coast in South America and Africa show the similarity of the extension in both continents. C. Coal and vegetation evidences. The distribution of coal and vegetation over South America, Africa, India, and Australia proves that they were together in geological past. The classical glacial deposits during Carboniferous period over these land masses resemble each other, which tells the story of togetherness. Today, they lie in different climatic zones. Apart from above evidences put forward by Wegener, other evidences are also there which support the idea of continental drift. D. Evidences from paleomagnetism. Paleomagnetism is the study of the direction of pole through ages. Magnetically susceptible minerals like hematite, pyrrhotite, magnetite, etc. get aligned with the magnetic pole of the Earth and recorded in the solidification of magma during that time. It is found that periodic changes have occurred and poles have wandered, which is not possible for the entire Earth. Hence, it is the twist and turn of the land block and not for the entire Earth, which has again explained that the continents have shifted their positions. E. Sea floor spreading. Along the mid-Atlantic ridge, the magma comes out at the seabed and gets solidified. A new zone is formed and this process is continuing since millions of years. It is leading for diversion of continental block and hence the size of the Atlantic Ocean is increasing, which is termed as sea floor spreading. It is the classic example of the shifting of continents. The explanation of continental drift through sea floor spreading and the study of paleomagnetism is commonly known as plate tectonics. Plate tectonics. The solid mantle plus upper crust form a comparatively rigid block termed as lithosphere. Mantle is partly molten between 100 to 250 km depth. The zone is said to be asthenosphere, also known as Moho discontinuity, a simplification of Mohorovičić, the name of the seismologist who discovered it. The lithosphere is broken into several blocks. These blocks are known as plates, which are moving over asthenosphere. There are 7 major plates. First, Eurasian plate. Second, African plate. Third, Indo-Australian plate. Fourth, Pacific plate. Fifth, North American plate. Sixth, South American plate. And seventh, Antarctic plate. Apart from these major plates, there are about 20 minor plates. A few important among them are Arabian plate, Philippine plate, Cocos plate, Nazca plate, Caribbean plate, Scotia plate, etc. The major and minor plates constitute the whole surface of the Earth. Plate tectonics is a method or way of understanding the land-water distribution of the Earth. Tectonics is a sort of movement of plates. Through the movement, internal forces are explained which are responsible for the distribution of Earth's crust, formation of mountain chains, and distribution of earthquakes and volcanism. Arthur Holmes, a British geologist in 1928-1929, proposed that the conventional currents exist underneath the lithosphere. The center of conventional current is not exactly known, but it is believed that it has an average depth of about 100 to 250 km below the surface. The inception of the current is initiated by heat generation due to radioactive. On the other hand, two sets of diverging thermal conventional currents bring the two plates together, and it is called convergent boundary, where subduction takes place. Plates of lithosphere are constantly in motion because of conventional currents. Their relative motion depends upon the force operating over them. Plate boundaries are very important and significant structural features. Boundaries are very distinct and easy to identify. They are associated with newly formed mountain systems, oceanic ridges, and trenches. Plates are moving continuously and have relative direction of movement. Based on the direction of movement, three types of plate boundaries can easily be identified. First, divergent boundary. Second, convergent boundary. Third, fracture or transform boundary fault. The conventional current is caused due to radioactivity. These currents get diverted on approaching the crust layer. Diverging currents produce tension at the contact zone of crust leading to fracture. Magnetic material penetrates into the fractures and gets solidified. This continuous process pushes the blocks in opposite direction and creates a new zone known as zone of construction. At convergent boundary, two adjacent plates come further and further closer to each other and collide. When both sides are of continental nature, a mountain formation is evident. When one of the two is continental and other maritime, again mountain, comes into being along the boundary. In this case, continental plates overrides the maritime. When both plates are of maritime, both of them break, subduct, and penetrate below, and hence trenches are formed. Along this boundary, earthquakes and volcanic activities are prominent. In all these three situations, surface area is reduced. Therefore, this is also known as zone of destruction. Transform fault is the one when two adjacent plates slide past each other. Direction of movement may be along or against, but they move parallel to each other. Therefore, neither there is any construction of fresh area nor it has any destruction. Hence, it is known as zone of preservation. Plates are not permanent features, but they vary in size and shape. Plates can split or get welded with adjoining plate. Almost all tectonic activities occur along the plate boundaries. Prior to the advent of plate tectonic theory, the continental drift theory, which was proposed by Wegener, was criticized, particularly about the forces. In fact, it was outrightly rejected in spite of apparent evidences. But further researches about the material of sea floor and paleo-magnetism supported the theory, but the proposition of plate tectonic theory in 1960s has solved the problem of the mechanism of movement. Plate tectonics versus earthquakes and volcanoes. The distribution of earthquakes and volcanoes over the globe clearly reveals that they are strongly associated with the boundaries of plate. Plate boundaries are the zones where every sort of tectonic activity does take place. The release of energy created because of the movement of plates is manifested in this zone in the form of earthquakes and volcanic eruptions. Conclusion. The surface of the earth is dynamic. This dynamism is due to the forces operating from inside the surface, endogenetic forces, as well as on the surface, atmospheric forces, exogenetic forces. It is existing on the earth while it is rotating and revolving. The surface is irregular. Hence, a sort of dynamic equilibrium is always in operation, which is termed as Isostasy. Apart from many scholars, the views of Airy and Pratt are more distinct. Airy propounded the idea of uniform density of all rocks on the surface, but has its roots depending upon the height of the column. A greater root will be found beneath the higher and lofty body of mountains and having smaller root under lower columns like plateau or plain. Pratt accepted that the rocks found on the earth have different densities. At a particular depth, the weight of all columns of varying height will be compensated. Hence, higher column of mass will have lower density and lower column will have higher density. Therefore, both of them are explaining the same problem of isostatic balance, but with different perspectives. The distribution of land and water on Earth's surface is not static. It has changed. It is changing and it will change in future too. This changed position is said to be continental drift in crude way, which was conceived by Wegener, but the mechanism explained by him was not scientific. Therefore, his ideas of continental drift were denounced in spite of his strong, unsuccessful and testifying evidences. With the concept of conventional current, theory of Holmes and proposition of plate tectonics, a new thinking came in, understanding the surface of the earth. Study on paleo-magnetism as well as sea floor spreading have supported the plate tectonics theory. According to this theory, the earth's surface is made up of several broken blocks of enormous size with great depth considered to be a plate. There are 7 bigger size plates and 27 smaller size plates. As per the concept of conventional current, their movement takes place in 3 possible ways. First, 2 adjacent plates move away and where a new zone is constructed. Second, 2 adjacent plates come closer and get subducted and where a zone is destroyed. Third, in which 2 adjacent plate sides pass each other where the margins of both plates are preserved. Because of these different tectonic activities, earthquakes and volcanoes are associated with plate margins.